Today we try to learn concept or direct formula of geometry and apply in few questions. Our first question is, how many non-congruent triangles are possible with perimeter 40 centimeters whose two sides are odd and one side is even integer? First check the formula or the concept, better say the formula, and try to apply the formula in this question. Here, how many triangles with integral sided length are possible provided their perimeter is 36 centimeter? What I am saying, we have a perimeter and the triangles with integral sided length means all sides are integer. We have two conditions. Working under these two conditions, we can find the Alcuin sequence which is given in this video. Then the direct formula for the total number of triangles is n square upon 48 when n is even, n plus 3 whole square divided by 48 when n is odd, and this bracket signifies the nearest integer. We have to find for the given perimeter 36. Here the perimeter is 36 which is even, so we have to apply n square upon 48. So 36 square divided by 48. If we solve this equation, we will get 27. Here this function is the nearest integer. For example, if suppose we will get 27.1 by some calculation or 0.13, then this would be 27. So this formula is very useful to find number of triangles if we have perimeter given with the sides are integral. There is no conditions. But we can generalize this formula for other conditions also. The first is sides are given. The first condition is. Second condition in this question is sides are integers. Otherwise, if we have perimeter given and condition is all sides odd, then we can also apply the same condition with some adjustment. If perimeter is given and all sides are even, then we can also apply this condition, n square by 48, n plus 3 whole square by 48. So we can apply this formula in three conditions: perimeter given, all sides integers; perimeter given, all sides are odd; perimeter given, all sides are even, according to few adjustment. Now the adjustment is, in a geometry, if we have odd, then we can say the odd should be in the form of 2n minus 1. We do not take odd as 2n plus 1 in the geometry. We'll see why we do not. If all sides are even, then the even should be in the term of 2n only. Odd 2n minus 1, even 2n. Let's apply this concept or formula in our question. Our question is, how many non-congruent triangles means non-equal triangles are possible with perimeter is 40. We have perimeter 40. Two sides are odd and one is even. So this formula which we have is not applicable for two odds, one even. So if we say the perimeter is 40, we work with the perimeter 40. The total number of triangles for the perimeter 40 is, since 40 is even, we apply n square upon 48, that is 40 square upon 48, an integral value. This is 33.33. So total numbers of triangle with the nearest integer is 33. So there are 33 triangles possible. Perimeter is 40 and all sides are integer. Since perimeter is even, so we can say all sides could be even. So say A is 2x, B is 2y, C is 2z, that is 40. That means x plus y plus z is nothing but 20. So we again make a new conditions. Perimeter is 20 with all sides are even, that is 2x, 2y, 2z. Again the 20 is even, so we apply n square by 48. So this becomes 20 square by 48, which is nothing but 8.33. So total triangle possible is 8, which is the nearest integer. If all sides even, we have 8 triangles. For A plus B plus C 40, we have only two conditions. All sides are even, or we can say two sides are odd and one is even. We have only two conditions. For the all integers, we have 33 triangles. For the all even, we have 8 triangles. So the rest 2 odd and 1 even. 33 minus 8 means 25 triangles possible, for which 2 numbers are, or 2 sides are odd and 1 side is even. I hope it is clear. Let's try the same concept in another question, just for clarity. Perimeter is 90 centimeter, means A plus B plus C side sum is 19 centimeters. So the total number of triangles for this is, we have 19 is odd, so we apply n plus 3, that is 19 plus 3 is 22 square divided by 48. Okay, so 22 square divided by 48 is equal to 10.08. So the nearest integer is 10. So we can say all sided are integers, then we have 10 triangles possible. But again, 2 sides even and 1 side is odd. If perimeter is odd, then we have 2 conditions. One condition is open. Apart from the open condition, means all sides are integer. The other condition is all could be odd, or 2 sides are even and 1 side is odd. We can apply formula only if there is no condition, only if all are the integers, or we can apply if all 3 are the odds. So we can say odd is 2x minus 1, A, that is 2y minus 1 is B, and 2z minus 1 is C, and the summation is 19. By solving this, we will get x plus y plus z is equal to, that is minus 3, 22 and 2 is 11. Again we will check x plus y plus z is nothing but the same condition. 11 is odd, so we apply n plus 3. So in this case, n plus 3 is 14 square divided by 48, which will give 4.08. So nearest integer is 4. We can say all integers 10 triangles, all odd than 4 triangles. So the condition for 2 even and 1 odd is nothing but 6, difference of 10 and 4. I hope it is clear. If you have perimeter given, then we can find integral triangles by this condition. If we have all odd, then again use the condition. If all even, then again use the condition. But 2 even, 1 odd, all the alternate case, we have to total minus the respective case. Now try to solve the same question, but the language is different. How many different sets S are possible? If S is a set having 3 elements, we can say 3 sides. All elements of set S are positive integers, so we are defining the integral condition in which 2 sides are odd. Again the condition is 2 odd and 1 is even. We do not have to work on this, we have to work on total minus total. It is known that sum of any 2 elements is greater than third, means we are saying if the elements are A plus B, then greater than the C. This is the condition for triangle. Sum of any 2 sides is greater than third side, and sum of all element is 80. So we can say sum of all element is nothing but the perimeter. A plus B plus C is 80. How many sets? Means with this condition we are looking for how many triangles are possible. 80 is even, so n square by 48. 80 square by 48 with nearest integer. We have the value of 80 square upon 48, which is 133.33, and the nearest integer is nothing but 133. So for only integral case, we have 133 set or say triangles. But 2 are odd and 1 is even. Again, it's a case of negation. We have to find all our odds. Say the all our odds. A is 2x, B is 2y, C is 2z. So we can say x plus y plus z is nothing but 40. Again, 40 is even. So we have to apply 40 square divided by 48. Again, the nearest integer is 33.33, which again in turns 33. So all integers 133, all evens 33. So the 2 odd and 1 even is 133 minus 33. So we have 100 required cases. So for this, the answer is option C, 100.